Hello everyone, in this video I am going to demonstrate Arduino Uno controlled current source. As you can see, this is my current source. This current source is controlled by Arduino Uno. So as you can see here, Arduino Uno is going to send specific commands, and based on these commands the gate to source voltage of the MOSFET is varied and the drain current of the MOSFET is controlled. So as you can see here in this setup, I am going to vary the gate to source voltage of the MOSFET using set of commands from the Arduino Uno. And based on these commands, since the gate to source voltage of the MOSFET varies, the drain current will change. So like this we can design an Arduino Uno controlled current source. So this is the setup. You can see this is the breadboard and here is the Arduino Uno sending the commands, and Arduino Uno is receiving a feedback also from the drain current, and it is confirming the same amount of current is flowing in the circuit. Let me show you the circuit diagram, then this setup will be very clear. So as you can see here, this is the setup. As you can see here, this is the setup. This is the far view of the setup. So here you can see there is a power supply of 24 volts DC, and you can see here this is a 330 ohms resistance, and here is the current source. You can see this is the current source. So this is the current source, and from here you can see this is MOSFET IRF840. There are two resistances here, and from this resistance I am getting a feedback, and this feedback is fed to this A0 pin of the Arduino Uno. This feedback is confirming the current in this loop. The drain current is confirmed by this feedback, the voltage across this feedback resistance with respect to ground. So here you can see Arduino Uno is sending specific commands. So based on these commands, I have set these three potentiometers into three different gate to source voltages, and these gate to source voltages are capable of tuning the circuit to 3 milliamps, 20 milliamps and 4 milliamps. So basically I have adjusted this potentiometer in such a way that it is going to adjust the drain current to 3 milliamps. This potentiometer is adjusted to deliver a drain current of 20 milliamps. This potentiometer is adjusted to deliver a drain current of 4 milliamps. And here is a common resistance. You can see here, this is the bypass resistance. So this resistance is kept so that the drain current doesn't go zero. You can see here, if we are not giving any voltages here, if there is no command, the gate will be floating, and this is not good for this MOSFET. That's why I have put this 100k resistance here, so that there is constant bias and there is a constant voltage here, and when these three signals are not present, any of these three signals are not present, the drain current will be different. So that is the drain current when there is no commands. So as you can see here, whenever there is a command, there will be three types of drain currents as per the circuit: 3 milliamps, 20 milliamps, 4 milliamps. We can set as many as we want here, and this resistance is provided. You can see here this resistance, 100k resistance, this is provided so that whenever there is no command, at least we should be having some drain current here in this channel. So this is how the circuit is designed. You can see this is how the circuit is designed. So here you can see these are my set of measurement probes. Here you can see the circuit is now delivering 3 milliampere DC, and the gate to source voltage is 0.3 volts DC. So based on the commands from Arduino Uno, this is the drain current, this current will change, and the current source will be able to give different types of combinations of currents based on the settings in these three resistances. You can see. So like this we can design an Arduino Uno controlled current source. Thanks a lot. Thanks for watching.